Welcome back, students. In this session we are going to completely concentrate on the dimension aspect of the derived physical quantity. So what exactly happens here is each and every physical quantity has its own dimension. What exactly is the dimension means? Dimension means it is the subdivision made based on the fundamental quantities. For example, all the derived physical quantity can be expressed in terms of the basic fundamental quantities. That is what is given in here. When a derived quantity is expressed in terms of the fundamental quantities, it can be written as the product of different powers of the fundamental quantities. What does that exactly means? Because if you just read this statement, it doesn't make any sense. But if you observe it very carefully, you will understand what they exactly are trying to say, because there are plenty of quantities that you will be coming across when we go deep into the subject. For example, we will be coming across force, we will be coming across viscosity, we will be coming across surface tension. So these are the different quantities that we derive or sometimes postulate. So what we are trying to say here is they could be exactly broken down using the basic fundamental quantities. The fundamental quantity is what I am trying to say is mass, time and length. Using those quantity, I can actually break down our derived quantity. So here I have shown you a small example. Just have a look at this. Force. Force is nothing but mass times acceleration. This is mass times acceleration. So again I am going to break my acceleration as mass into velocity by time. See, so now I have actually broken down my force into mass, velocity and time, and velocity could be further broken down into length by time. So now what I actually understand is this is equal to mass into length divided by time squared. This is how I have brought them down. If you understand now, force is a derived quantity. I can derive it from anywhere I want. So now the force is completely rewritten as mass times length by time squared. So I have used the fundamental quantity to break down my physical quantity. So now what I will be doing is I will be expressing the dimension of the force in 1 in the mass, m power 1, 1 in length, L power 1 and T power minus 2. So this is the dimension of my force. So what we actually acquire by doing this is I will be able to simplify all my derivatives using the fundamental quantities. So I will get to know how they exactly operate, how much amount of length, mass and time is actually inside all the physical quantities. So this is what I exactly do with almost all the quantities. So this being your first chapter, right now you might not be so familiar with the other units like permittivity or susceptibility or magnetic field or magnetic induction. So you might not be so familiar with this. For that, what I have just did is I have given you a huge tabular column where I am able to tabulate all the physical quantities that are possible in this particular chapter, and I have also tried writing their dimensions. Here you will find their units. Okay, for example, taking the acceleration in, acceleration is nothing but meters per second squared, and if you observe, you can see m power 0 indicating that for acceleration we don't have any role of the mass, but the length is raised to the power 1 and time is raised to the power minus 2. Likewise, the momentums are very basic things which we are studying right from our elementary classes, where momentum is nothing but m into v, mass times velocity. Already we know the dimension for the velocity, which is m power 0, L power 1 and T power minus 1. To that, To that I am just adding a mass. You see, so we just got m power 1 here and we don't have that m power 1 over here. So this is how you compare one quantity to another, and we can simply write the dimension for all the quantities that are possible. So now coming to force, I think we have already dealt with the force, which is mass times acceleration. Okay, coming to pressure. What is pressure? Pressure is nothing but force per area. We already know the dimension for the force here, which is m power 1, L power 1 and T power minus 2. And all you have to just do is divide it with the area. What do you mean by area? Area is nothing but square of the length. So observe here, m power 1, L power minus 1 and T power minus 2. The time term and the mass term haven't get altered. Why? Because you are actually dividing the force with the square of the length term. So that is the reason why the length term is the only one that is going to get altered over here. And the unit for the pressure is pascals. Likewise, for the kinetic energy, we use joules. You might wonder, sir, how to break down the kinetic energy? Okay, when you go for a chapter called work, energy and power, there I will be teaching you the relationship between work and kinetic energy. Actually, both are same. Work and kinetic energy both are same. So kinetic energy is equal to work, work is equal to force into displacement. So listen, it is written as force into displacement. Again, what will I do? I already know what is the expression for the force. It is m L power 1 T power minus 2. To that, I will just multiply a length quantity, which is your displacement. So it becomes m power 1, L power 2, T power minus 2. You see these two things. The only difference is 2 to the power, 2 over the L. So that is because you are multiplying the displacement, the length quantity to the force. We already know the dimension for the force. So this is how easily we do these things. And remember one thing, whenever you were asked to derive something, what you have to make sure is the dimension on the left and right side of the equation should always be the same. If the dimension doesn't match on the left and right side of the equation, it is very sure that you have went wrong somewhere. Okay, so dimension could also be used to check the equation's genuinity. Then, as far as the exam perspective is concerned, whenever you go for some competitive exam, few problems could actually be directly solved just by checking the dimension. Because for a numerical problem, you can see that all the 4 options will be like an equation. In that case, the very first thing that you have to do is you have to check the dimension for each and every option. Because in the question, for example, let's say they are asking you to find time in the question and they have given you 4 options. Make sure that all the 4 options are in the dimension of time. Only then you will be permitted to proceed forward. In case if any 2, mostly it will be like that, in case any 2 of the object doesn't have the dimension of the time, please feel free to eliminate them. So now you get reduced to 2. So among these 2 options, you will be able to choose one. So this is the basic technique which we will be using to solve different numerical problems, which I will be showing you in the future. So right now, we will just worry about writing the equations. You see, again, density. Density is nothing but mass by volume. See, simple. You see, time term is 0 there. Like that, I have managed to write the dimensions for almost all the physical quantities. Right now, you might not be familiar with most of the them. Like, you might not be familiar with the torque, you might not be familiar with the surface tension, you might not be familiar with the coefficient of viscosity. So, after going through all the chapters in class 11, I strongly insist you to come back to this particular slide to see how the dimensions are being calculated, because it is merely impossible for anybody to remember all the dimensions. You cannot remember them. You can only derive them down. to derive them down, you should first know how the quantities are being broken down, from where it is being derived. Only if you know that, you can derive it down. In the same way, writing the units too. Once you are familiar with the unit, it is very easy for you to write the dimensions for them, right? So, that is how it is done. Likewise, when you come to heat, heat is another form of energy. Here, look, temperature has its unit of Kelvin. Adding to that, in the dimension part, we will have theta. Okay, that is the only additional thing that you are supposed to do. Okay, then you see, wherever you encounter your temperature, wherever you come across temperature, there is an additional dimension you have to put in, which is theta. Likewise, when you go for electricity, okay, you will come across this electricity in your class 12. Over there, when you come across current, then you have to introduce another unit, A. A stands for ampere. Okay, whenever you come across current, you have to write it like this, because Q is equal to I into T. Okay, Q is equal to I into T. See, for I, A power 1, and for T, T power 1, whereas M power 0 and L power 0, which means that it doesn't have the dimension of mass and length at all. It doesn't have those. It only has the dimension of the current and time. So, this is how I reduce this. Okay. So, like that, the different quantities are being written here. Right now, you might not be familiar with these quantities, but when you start studying your class 12, you will be slowly understanding from where these quantities are being derived down. Capacitance, electric potential, permittivity of free space, dielectric constants, resistance, and things like that. Okay, now you see, these are also some of the other quantities which involves current in them. Okay, self-inductance, magnetic flux, magnetic induction, magnetic intensity, and stuffs like that. Okay, so now we go for this quantity. These quantities have same dimension. I strongly insist you to remember these things, because this might come in handy when you go for some numerical questions, because you don't have to worry about much. You see, frequency, angular velocity, and gradient and decay constant. These all quantities have a same unit. They share same unit, and the unit is per second. Per second. That is the reason why you get T power minus 1. Likewise, work, internal energy, potential energy, kinetic energy, torque, and moment of force. Everything share an equal unit. What is the unit? Newton meter. Okay, let me write it down. Unit is Newton meter. Here it is second inverse. Okay, so all the quantities actually share this. Potential energy, kinetic energy, torque, and everything. Coming down here, you see pressure, stress, Young's modulus, bulk modulus, modulus of rigidity, and energy density share the same unit. And what do you think is the unit for them? They have Newton per meter squared. So, the unit for all the quantities are Newton per meter squared, and using this you can directly write the dimension, which is M power 1, L power minus 1, and T power minus 2. Whereas the momentum and impulse have the same unit, acceleration due to gravity and gravitational field intensity have the same unit, thrust, force, weight, and energy gradient has its own unit, angular momentum and Planck's constant have its own unit. Likewise, these are the quantities which have their own units, which are similar to the other things. Again, I also have different set of other quantities. So, I strongly recommend you to go through these slides and try to remember these things. Okay, if this is your first chapter, as I have already said, it will be very difficult for you to remember these things, because you will be studying these things for the very first time. Okay, so now what I would like to do is, with this, we come to the end of this session. Here what we have discussed and what we have concluded in this session is writing the dimension for each and every physical quantity is very important, because physical quantity indirectly indicates how the basic fundamental quantities are being broken down from there, and it will also be very helpful for you to solve different problems when you go for your numerical sessions. So now in the next session what I will be teaching you is how the numbers are dealt here, because there are plenty of decimal places that you have to deal with, and how to round off the numbers, how the error calculations are done, and all the other things will be dealt in the next session. So I will again meet you in the next session. Thank you.